Going live. All right, everybody.
Okay, and that's a first for me.
Okay, guys. I want to thank you for joining this awesome hangout. I'm actually here with Professor Phil Bell. Oh, actually, let me turn off the audio here. I'm sorry. Whoop. All right, there we go. I'm here with Professor Phil Bell. He is a rocket scientist, and we're going to have a nice, friendly chat about all the things concerning I guess, the proofs on both ends. And we're going to have a nice conversation and see uh, what can come out of it, what we can understand from each other, what we can learn from each other. He's actually a pretty nice gentleman. I've already had a few conversations with him earlier, and he's a very nice guy. So I want you guys to be nice to him. Just because he's on the other side of the fence doesn't mean he's our enemy. He's just a person, and he has some views, and we're going to discuss those. So please welcome Professor Phil Bell.
Thank you. Thanks very much. And thanks very much for having me on your show.
Yeah, for sure. Thank you. It's a pleasure.
Okay. Now, I've got one little issue. I can't actually see you because I don't know, I've done something and I don't know what I have. So
Okay,
I'm just wondering how. Can you see me?
I can see you.
Oh, okay, well, I can't see you, unfortunately. So I'm not sure how to resolve that. But
Okay.
let's see.
Yeah, sure. Take a second.
Just,
I'm going to
just,
go
just,
ahead
just,
and
just yeah,
welcome
yeah,
some
just,
people in the chat.
yeah, please, yeah, yeah. Okay,
So,
yeah, go ahead.
frequencies, what's up, my man? How you doing? Good to see you here. I know you're always showing up to my live streams. I appreciate it, brother. Let's see if anybody else shows up. And then if you get a chance, please hit that thumbs up and try to share this video with others. The more people see this, the better, because it's about truth, guys. So let's get to the truth, right? So,
Yeah, exactly right.
yeah. So, Professor
Oh,
Phil, you
that's much better.
still? Okay, cool. And we got more
Okay,
watchers
yeah,
coming in too, so that's great. People are
yeah. Oh,
entering.
good to go. Yeah,
So,
that's good.
guys, who are watching live, just to make sure, because I had to do this kind of last minute with the audio and video. So, if you're having trouble listening to me or to Phil, please just mention it in the chat here, and that way I can kind of get at it right away. Now, mind you, there is a little bit of a delay on the chat, so it's not like I'm going to be able to see it right away. So, just give me a second as I constantly check that. So,
No problem.
let's go ahead and just kind of get started anyway.
Okay, yeah, yeah. No worries. Okay, Steve, you go ahead.
Yeah, yeah. So, I guess my question to you, Professor Phil, is that so you're a rocket scientist, right?
Yes.
You're
Let me just put that straight.
sure.
Uh, my although I work with rockets, I'm actually in the satellite area. So my job is to actually put the satellites into space. So the rockets take them up there. The rockets let go of them. They're now in a transit orbit or a transfer orbit, and my job is to put them in the right place.
All right. So it's like orbit
Okay.
insertion. That's sort of
Yeah, yeah. So basically, rockets don't just take them straight to where they're meant to go and then just let them go, and we actually have to do some work to get it right.
okay. Okay.
Yep.
So you also teach, is that correct?
Yes, I do. I've been teaching now for probably 35 years.
That's
So
awesome.
it's been quite a while, and not always physics. I'm also a chemistry professor as well. But these days I mainly teach physics.
That's beautiful.
Yeah,
Now, we
yeah,
were having a little bit of a conversation before we got started, and then
yeah,
you mentioned to me, because we were talking about discernment and things like that, and you said
yeah.
how you ask your class to basically prove that the Earth is not
Mm.
flat, as part
Yes,
of
yeah,
yeah. Can you explain a little
yeah,
bit about that?
yes. I think well, I sort of fell into this understanding about flat Earth. Probably about 12 months ago, and after looking at some of those videos that I did come across, I thought this is some really good material for my class. And what it does for me is prove to me that they understand some of the principles behind what we do,
Yeah.
and what physics is about, and in my case, what orbital mechanics is about, and what drives those things. How does the Earth work? How does the atmosphere work? all of those sort of things are all combined.
Awesome.
Yeah.
So, you've done very have you done some research into flat Earth? You're saying so you've looked into some of the I
Uh,
guess are flat Earth proofs. Have you heard about any of them?
yeah. Look. I guess I've seen probably most of it now.
Okay.
I've had a good look at it, and I did a lot of that research for my class.
Okay.
Okay, so in order to get all of this material together for my class, and so I'd better do a good job because they're probably watching.
All right. Okay. Well, um, so I guess we should just kind of jump into things because
Sure,
I have some questions. I'm sure you have some questions, and I'm sure
please.
everybody out there has some questions. Oh, the
Look,
chat.
I think yeah, probably the best thing to do is if you because obviously uh, when we started this was going to be about rockets
Yeah.
and rockets in space and stuff, but I'm quite happy to discuss any of the flat Earth things that you want to. So anything that bothers you that says, look,
Yeah.
I think the Earth is flat because of that, put it to me.
Okay.
You know, and I'll be straight with you. I'm not the fountain of all knowledge, even though I teach.
Yeah.
There are things that are I might, if I don't know, I'll tell you I don't know.
Okay. All right.
Okay,
That's
so
awesome.
I won't be making anything up because if I tell you something, then I know it is from the evidence.
Okay.
Okay,
So, yeah. So, I guess I
so
have a few questions. Should I go first,
go
or?
ahead, please, please,
All
please
right.
go ahead.
So, right off the bat, I guess this is a good question. I'll start off with this first one because we already
Yeah,
have people asking about this in the chat, and and
absolutely.
and I guess what it seems that they're asking is frequencies illuminate said ask if rockets are reusable when they put them when they pull them from the ocean. Well, what he's saying is, I guess he's saying, uh, how can you prove that they're actually going into space in the first place and not into the ocean?
Okay, that's all right. Fair enough.
Yeah.
Okay, so the reason that you would think that they might be going to the ocean is because if you're standing anywhere near, well, normally you wouldn't be anywhere near inside 5 to 10 kilometers away from a launch anyway. I have never been more than about a kilometer away from a launch because it's a very dangerous place to be.
Hmm.
It's there's every likelihood a rocket can fail and and it will kill people who are in the vicinity. Okay, we're talking about an explosion consisting of about 40 tons of liquid fuel, for instance, in our case. This is a huge amount of fuel to blow up, and we've got a tube there sitting there and igniting 40 tons of fuel. Believe me, there's a lot that can go wrong,
Okay.
and it has gone wrong, and so we keep people away. But now, to get back to that point, when you are away and you are, 10 kilometers away, and you're looking up in the sky, you're going to see a rocket that's going to go up pretty high, and then it's going to start to curve. And we actually have what's called a gimbal controller on a rocket. Okay, so it's not mentioned much this, but for instance, when we're launching a geostationary rocket from India. So we're launching it from the west coast of India. Sorry, from the east coast of India,
Yeah.
from Chennai, and then that rocket's going to go. It's going to go slightly south, and then towards Indonesia. Okay, so it's going to go. Indonesia is sort of slightly south and then further east of the Indian coast. Indonesia is actually where the equator is.
Hmm.
Now, we need to do a bit of a roll. So the rocket's going to go up and then it's going to roll over. The gimbal controller is going to roll the rocket so that it heads towards the south and then up towards the equator. By the time, probably within I'd say a couple of hours, it will be. We have stations in Brazil, which is also at the equator, and then all the way back to Nairobi in Kenya, which is also at the equator. Right. So now, at that point, now the rocket is now orbiting Earth.
Okay, so I have a question. Okay,
Sure.
so if you look at a lot of the rocket launches, like going from, like, let's say, in Florida, Cape Canaveral or whatever,
Yep.
they
Yep.
seem to be on this arc. So they go up, and then they
Mm-hmm.
sort of reach their sort of what
Mm.
is appears to us as being,
Yeah.
the very apex of their
Yeah.
curve,
Of
and
the,
then they
and
start
then they come down.
to come down.
Yeah.
Now, here's
Yeah.
my question to you, and
Sure.
this is actually one of the reasons why I do believe that they are just being shot directly into the ocean, and that is
Okay.
an observer looking onto the horizon. Like, average observer can see about 3 miles, right?
Yes.
So
Correct.
you have these objects, right, where they start off and they're about a certain size and they're going up, and then as they're coming down, they're at a certain size. Now, one thing that we need to understand is if the Earth is 25,000 miles in circumference, or
Mm-hmm.
roughly, I'm rounding up, of course. Um, that arc where you're seeing it go down is obviously, it's inserting itself into the curvature of our sky. So when it reaches the quote unquote apex, I'm not sure if I'm correct on this. It
Yep.
should
Yep.
be
You're right.
it should be at some point at least horizontal with uh, the
I.
curvature arcing of the sky, right? That's
Yep.
the
I get
point.
that.
Now the problem with that is that when we see the rocket pass through that apex point and start coming down, when it's passing the point of the curvature point,
It
our
looks like it's not. It's going to come down before the horizon.
exactly. The problem with that is the
Okay.
rocket is ultimately roughly the same size as it was when it was at the apex point as it starts coming down. Now, if it was inserting itself into orbit and actually curving with the curvature of the Earth, I mean, it would literally just fade off at the apex. We would never see the other receiving end of that curve. We would only be able to see that part because the arc of the Earth is so massive. It's so
Mm.
huge, and it would be
Yep.
literally like seeing over 1,000 miles, or I don't know how far they launched themselves, but it would literally
Yeah.
be like impossible to see them remain roughly the same shape, the same size
Mm.
as they make that curve during that launch. Now, I know that when things disappear into the horizon, they shrink up into a point where they almost are
Yes.
invisible, right?
Correct.
But we don't see that when we see these arcs. We
Okay.
actually see them pop out the other end of the arc. So I
Sure.
mean,
Would you like an explanation for that?
yes, please, yes.
Oh, absolutely. Okay, when you see a rocket going up and you think that that rocket is the same size, uh, you are actually seeing that rocket a long, long, long way away. Okay, thousands of kilometers away, thousands of oh, let's see, in kilometers, probably two, mm, 50, 60 kilometers away at that point, that you still see, uh, probably about 80 kilometers before you won't see it anymore.
Okay.
So what happens at this stage is rockets have, so you actually not seeing the rockets itself, you're seeing the exhaust gas,
Hmm.
okay, the burning fuel. That's what you're looking at. Now, as this rocket goes up further and further and further into the atmosphere is getting thinner and thinner. That plume of burning fuel is getting wider and wider. It's getting bigger and bigger. So as it's going further and further away, and the plume is getting bigger and bigger, yes, the object is getting smaller, but because of that plume's getting bigger, it looks as though that object is the same size. Okay, so we as rocket scientists, we're quite aware of this phenomenon that you're actually talking about, and we're looking at that and we think that, well, that's quite awesome, that it looks like that, but in fact we know, because we can see the telemetry figures, we know exactly how high that rocket is and where we know exactly where it is. So
So
you're looking at a rocket going over from Canaveral.
yeah.
That rocket is a long, long way away by the time you think that it might be coming back down again. And it's way, way past the horizon at that stage.
Okay. Well, I I I feel like a lot of that is sort of putting your faith into the data that is sort of supporting this claim. Because, like you said it appears this way, yet the data says it's this way. And to me, I can say, I mean, are you putting your faith into the data? Is what I'm saying. Like, is the information telling you this? Because if it is just information, I mean, there
Mm.
you
Well,
fraudulent information can be created. That's not hard.
sure. Look, we've got 2 points of reference.
Okay.
One is that these days we put a camera on, at least on the second stage. So in our case, I can't speak for NASA. Okay, and I don't speak for NASA. Okay, so your T-shirt is fine. Okay, but we do put cameras on second stage rockets, and that's important these days now that we can do that, because we it's very critical for us to know when those stages happen, and that we have a proper burning that takes place for second stages and third stages and so on. Okay, so it's critical for that. So we have a reference from the actual camera that's on the rocket itself, and then we have the telemetry data. We've got absolutely no reason not to believe the telemetry data, because we use this kind of data in ballistics and in all sorts of things that have been proven time and time again. So we know that they're there. We know the data works. We know when it goes up, and we know when it comes down. We know when the thing separates. Quite often, you can actually see the separations. So, in fact, you can always see the separations if it's at nighttime, for instance. Okay, you may not see it in a daytime launch. Um, but yeah, look, this the telemetry is pretty straightforward. The way that rocket speed is measured, um, the amount of fuel that's consumed, we pretty much know quite a lot about what that rocket is doing, and we have the camera as well, so we've got the visual on it. And
So, sorry, I didn't mean to interrupt.
that's okay.
You said you have no reason not to believe the
Mm,
telemetry data. Um,
mm.
I want to give you a reason to not believe the telemetry data, and
Sure,
I'm gonna explain why. Because
go go for it.
okay, so we understand that around the time where these rockets were being developed for space travel and whatnot, I don't know if you're actually familiar with the origin of NASA or whatever. Phil, actually, you just dropped out visually. Are you still there? And by the way, guys, Phil's in India right now, so there will probably be little trip ups like this. So hopefully we can get him back. Um, Phil, are you still there? Um, hello, Phil. If you can hear me, you might want to drop out and re-sign on, just like recall me back. That'd be actually the best way to do it. So if you can hear my voice right now, why don't you go ahead and just hang up and just call me back, and hopefully that will reinstate your audio and video. So, all right. Well, guys, I don't know what's going on. Obviously, it appears that we were cut off. Um, I don't think he hung up. We actually spoke beforehand. He was a really nice gentleman. He actually is looking for the truth, at least I believe so. And I hope that he's willing to continue the conversation. And he seems like a very nice guy. If he can hear me, like I said, please just drop off the call and try calling back afterwards and see if that works. But guys, while you're here with me, just letting you know how this all kind of happened. So, um, well, there I am, but my video is gone for whatever reason. Uh, Please stand by. All right, hold on, guys. Hold on, guys. Let's get to the bottom of this. All right, I'm back, but I see no Phil, so hopefully he'll rejoin the chat. And he actually has my contact information, so I'm sure he will say something. I'm gonna message him right now just to make sure he's good. Yeah, I don't know what happened, guys. If not, we will have to reschedule this. Now he was telling me that he is going to India. I mean, he's in India right now, but he was going to be doing some work with them for the next few weeks. So if things don't pan out and he doesn't jump on, we'll probably have to reschedule this chat for after he's done. Or you know, okay, look, he just jumped on the chat. He's going to be in a second. Okay, cool. All right. Technical difficulties, guys. Hey, he's in India. I mean, what do you expect? The connection is not going to be the best. And I was just going to get to the good part, and that's when it always cuts off, right, guys? That's how it works here. So please stand by. Thanks for everybody being here. Hey, by the way, let me go on the chat here and give everybody some shout out. We got Spherical Cow, Globehead No More, Isaiah Smith. Um, let's see, comment exclamation point. Mr. Akilwill, Akilwill, Akilwill. Hope I said that right. Flat Earth Victoria, Canada. Thanks for being here. Um, Her eyes on level. How you doing? Microsoft update. Shut down my computer. I'll get back on as soon as it's up again. All right, no problem. So, Flat Earth vegans, what's up? Hey guys, yeah, we're just having this great conversation with a rocket scientist. Awesome guy, awesome guy. He will be back shortly. He had some issues with his computer, so he's got to sign back in and jump back on. So give it some time. For now, you guys are stuck with just plain old me, and hopefully that's not boring for you. But yeah, I mean, if you guys got some great questions for me to ask him, please just post it in the chat, and I'll do my best to kind of go through them and see if I can help him out. Now, the guy seems fairly open to this conversation. He's very intrigued with flat earthers, and what I want to do is I could go down the route and be like, hey, this and this and that, and try to come at it from an attacking angle, but I don't want to do that, guys. What I want to do is try to reason with him because he seems like a very intelligent guy, and I think that truth will shine through. Like if I can ask him the right questions and get him to think, maybe plant that seed, we can see where this goes. I get it. You guys, in your eyes, he's working with the enemy, but to me, I think he may or may not understand what's going on. So that's what we're here to do. So yeah, the indoctrination is strong with this one. Hey, what's up, deep inside the rabbit hole? How you doing, Larry? How's it going? Isaiah, back again. So yeah, so that's kind of generally why. Because I had this structured as a debate, and originally I was gonna have Mac, kind of be the guy running the debate, and because I didn't get in touch with Phil at the right time, everything came out last minute. He hit me up this morning. I was like, yeah, let's do it. So we just turned it into a conversation, and I think that was probably the best decision because I didn't want to just shoot this guy down and then just and end it. I want to have a conversation. I want to be open. I want to get to know this guy. I want him to get to know us and what we're all about. And that's the thing is like, flat earth is so taboo. The fact that this guy is actually looking into it, he's actually researching it and talking to his class about it, it just says that he has an open spirit and he's willing to get to the truth, whatever that may concern. So maybe I'm making assumptions. I don't know. But me, guys. I've always had big heart for my fellow peoples, and all I want to do is just get to the truth. That's the most important thing of it all. So, um, my hopes is that this conversation can bring that, and see if we can open his eyes, if you will, and at least show him some of the the very good contradictions to the heliocentric model, because I have a few I do want to talk about. So yes, Flat Earth Vegans, they just mentioned how can rockets work in a vacuum. Yeah, we're going to be talking about that too. All right, so Professor Phil Bell is ready. He's going to be jumping on in a second. So guys, hang out. Please, thank you for being patient. Thank you for putting up with the technical difficulties. In the beginning, it was actually my fault. So um, I was running into issues with my audio and I wasn't hearing myself. So I had to like last minute, do some stuff to figure it out. So that's what I did. And yeah, yeah, and just like Professor Phil Bell said, the truth is what you get from me. And what a lovely thing to say. He just wants to speak from his heart and he just wants to be honest. And I think that's what's most important. So, okay. Karen B's here. Hey, what's up? Um, yeah, guys, just hang out. He should be back on shortly. We had some technical difficulties. Now, remember, he is in India, so we might even get cut off again. This might not have been the only time. He said it was a Microsoft thing, but it could also be a connection thing later on. Hopefully not, and hopefully we don't get any like crazy censoring or anybody shutting us down or nothing like that. But yeah, so I guess we'll just hang out. I'm just kind of babbling at this moment, guys. I'm sorry. Uh, he wants me to make that call. Ooh, if I do, I might have to end the stream. So let me see if I can at least send him an invite. Um, let's see if that works. Uh, all right. I'll send him this link. All right, guys. Let's hope he gets back on, man. Let's hope. So for the time being, just hang out, and I will keep my eye on the chat. And oh, Flat Earth Vegans. Yeah, where did I find this guy? So funny thing. So basically, I don't know if you guys are familiar with. I have the Flat Earth Activist channel. It's a 24-hour, 24/7 live stream for flat Earth activism, and he actually saw me. I guess I was on a suggested live feed, and he's just like, "Hey, a flat earther, let me go have a conversation with this guy." And then we had like like a little bit of a 5 to 10 minute like debate via comments, and it went back and forth for a day, like in the comment section of the video. And yeah, so then after that we spoke via email, and then actually I challenged him to a debate, and I was just like, let's do this. And then after I spoke with him, and everything, I realized, he was seemed like a pretty good guy. So we'll see. We'll see if we can reason and get some understanding to come out of this. So yeah, guys, just hang in there. Phil, I sent you the link via your Hangout. So if you go to our conversations, if you go to Google Hangouts, and then go under Conversations tab on the left, and then you'll see a conversation between me and you that's already ongoing. On the bottom there, if you can't click that video, what you can do is you can click that link. And actually, just to make it easy for you, I'm going to email you the link as well, just to make it that much easier for you. So hopefully he can get back on. Uh, okay. I don't know. Still nothing. Oh, that's why. Well, okay. There you are.
Okay.
I think
We're,
I hear you. I
we're,
think I hear you. All right.
okay, just hang on a second. I'll put my headphones back on.
Sure.
Where did I put them? Just hang on a second.
What's up, Glowbusters? What's up,
All right,
guys?
no, we're all good.
Cool.
Okay,
Yeah, I was just talking to the
all right.
chat, just trying to fill in the
Yes, so
void.
I heard some of it because I lost that down. So yeah, I'm pretty cool. It's okay.
Yeah,
Yeah,
yeah.
no, no,
No, I really do
no.
appreciate you being here. Everybody here is they're just like they're like rocket scientists. You gotta give this guy something like and I told him
Okay.
it's like I'm not trying to berate you or make you feel like that way. I feel like you have an open heart and an open spirit, and I just like the fact that we're able to
Oh,
have this
it's getting
conversation.
confusing over here.
Yeah. All right. So you're probably listening to the audio from the live stream, so you might want to mute YouTube.
Okay, hang on a second. I'll work out how to do that.
Okay. All right,
Okay,
guys.
is that any better?
Yes. Yes.
Okay.
Yes. Perfect.
All right, here we go.
All right. Okay.
Yep.
So where were we? I forgot where we left off.
Okay.
Um.
It doesn't matter. Just pick it. Pick it. Look
Okay.
at one of those questions that they've got up there and answer and ask me one of those.
So, oh yeah. Okay, I remember what I was talking about.
Yeah.
I was saying, yeah, basically that's what I wanted to do. I wanted to give you an opportunity to kind of see the other side and to
Sure.
allow you to see that because like you said the data it you're agreeing with the data. There's no reason why it should say otherwise, but I'm saying like there are plenty of reasons why it should say otherwise and why it
Okay.
could be telling you otherwise. And let's just kind of go over a couple things that are
Okay.
flat Earth
Sure.
proofs
Sure.
that.
Well, you tell me why you think the data might be wrong.
Okay.
Let's. Why don't we start with that?
All right. So we'll start with the easiest one of them all.
Hmm.
Okay, so I get that when it comes to like the math, to the science and everything, you might be on point with what you've learned and understand, and it all works out and it all checks out. So I don't deny that
Yeah.
you know what you know. So I'm
Yeah.
not gonna
Sure.
address that and say, oh, are you wrong because of this? What I want you to see is the other side of the story and why we disregard that data, why we put that data aside and say, okay, to us that's just hearsay because the truth says otherwise. And here's what I'm saying is what we believe to be the truth. So
Okay.
first things first, we can see way too far, and I'm not talking about like way too far, like a little bit way too far. Um, Sorry, the stream is going slow for a second. Give it a second. It's going to pick back up.
Yeah.
All right, cool. So I'm not. We can see way too far. I'm not talking like, you know, crazy. I'm not talking like. What I'm saying is we can see. Okay,
I
so
get it. You can see more than you'd expect to see if the Earth was curved.
and it gets even more ridiculous, is what I'm saying.
Yeah.
It's like
Sure.
okay,
Sure.
so the longest distance photography record is about
Mhm.
270 miles. Now,
Yeah.
we know that
Oh.
in
Yeah.
the long distance records, they do not hand them out for optical illusions, phantom organa, or any sort of light refraction. You're looking
But that.
for physical objects at long
Yeah.
distances.
And they have no restriction on how high you can go to take that photography either.
That's a good point. That's a good point. And then this is where that gets crazy. So how high do you have to be? And and I'm just saying this because there's a lot of evidence that supports this. How high do you have to be to see 1,000 miles into the distance?
Okay. All right. Okay. Look, I can't tell you that off the top of my head. I'd have to do the calculations.
Of course, of course.
However,
Yeah.
however, let me just tell you how a scientist would think. Okay.
Okay.
All right, and then you can work it out from there. So let's say, for instance, I came across some flat Earth, some proof. Okay, and it looked really convincing, and yet I know what I'm doing. So
Hmm.
I'm thinking, hang on a second. I've got two very, very compelling pieces of evidence, okay, that are contradicting each other. So now I've got to look at that and I've got to say, well, uh, I've got to put that in line in terms of probability. Okay, so let's say, for instance, you saying, well, we can see too far, and I'm saying to you, my satellites can see the Earth from 36,000 kilometers. Okay, so now I look at that and I think there must be something seriously wrong with my camera on my satellite. Okay, or There must be some explanation for why you can see that distance. So, as a scientist, I would put a hypothesis to both of those and then test them. Now, I would wager that that something that can see 270 kilometers away would be at least 200 or 300 meters up before you could see something that maybe more that before you could see something that far away. If you were 1,000 meters up, you'd have to see. Oh, yeah, I'd be guessing, but it'll be kilometers, many kilometers ahead of you. Right. So how far you can see is proportional to the height that you are, and we can tell this because the higher you go. Have you ever been up in a parachute?
Uh,
Have you
Airplane.
ever been? Yeah. Well, you've been in an airplane, obviously,
Hmm.
but have you been up? It's a lot more intimate, if you like, your relationship with the Earth when you're in a parachute. Okay, so when you're coming down in a parachute, your life's on the line, and you're thinking about you. If you got time, you're looking around and you're looking at the Earth as it's approaching you. Now, when you're up there, you can see a fair distance away. Okay, and as you come down in that parachute, the Earth gets closer and closer to you. The less and less you can see. You can't see as far as you could before. So you might be up there. You'll see all the farms way out there in the distance. You can see all the farms. You can see all around you. You can see for ages. You can see over the top of mountains ahead of you. And then as you come down to the Earth, you don't see those anymore. Even though from when you're standing on the ground, it looks like it's flat all the way there. But when you're actually coming down in the parachute, you can actually see how the Earth comes up at you.
Okay.
So so you look at that from a scientist's point of view, and you say, well, okay, I'll look at that data and I'll compare it to that data. Now, I've now got to ask myself which one of those two models, those two hypotheses, explains what we see more accurately. It's not a case of saying which one of we're not even saying which one of these is the truth. We're saying which one of these fits better what I'm looking at.
Okay.
Okay, and that's essentially how science is not about truth. It's the very first thing I say to all of my students the first day I stand up in my lecture, and I tell them, if you want truth, go to church. If you want science, stay here. But we're not about truth. Okay, we are about finding the best model, the best situation that will fit what we observe. And the purpose for doing that is so that we can predict, so that I can make a prediction about how much fuel to put in a rocket. So I can make a prediction about how much thrust to give my satellite so that it can go in the correct orbit. That is
Okay.
precisely what I'm doing. It's about making predictions so that the things that I want to do can work, and they do.
All right. May I address some of those comments that you made?
Sure, absolutely.
Awesome. So let's go back. Let's go back. You said you're talking about how the data itself uh, is conflicting with the I see too far. It's like you said, you have satellite pictures of the Earth, and these satellite pictures are saying otherwise, right? So
Oh, I'm
I
not saying that they're conflicting. I'm saying that if that was the premise that you made,
right,
I
right.
don't believe there's a conflict. I,
Okay,
I, I don't see a conflict because
I know
I,
that.
I think those photographs are taken up from high enough so that you would see as far as you need to see,
I
as far as
actually
those photographs go.
we agree
Okay?
more than it seems. So I don't know if you're familiar with the Google Loon project. Have you heard about Google Loon?
No, I don't know. No.
Okay, so
Explain to me.
essentially it is basically a satellite system, sort of a
Mm,
satellite type system that is actually launched by balloons. And the
okay.
way they work is they work exactly pretty much almost essentially the same as the way satellites work, and they circle around during these high wind areas and high up in our atmosphere. And what they do is
Mm-hmm.
they reach a certain elevation where they can
Mm-hmm.
catch these very quick updrafts, and they can actually control the direction of these things to where they can literally be constant on repetition, and they launch like thousands of balloons a day. So they're
Mm-hmm.
constantly using essentially the same systems of satellites. So what I want to propose to you is the possibility that the data, the information, the imagery can all be just as legitimate with a satellite sort of balloon system, or even high altitude aircraft as well. So I wanted to address that,
Sure.
just
Okay.
to see
Sure.
that you understand that that is also a possibility. Now,
Look. Yeah.
now you
Well,
you you're go ahead. I'm sorry.
no, it's okay. Let me address that. Okay.
Sure, sure.
All right. I don't know about that system that you're talking about. I've my work's cut out for me in as a professor and also as a scientist. So it's cut out. So I haven't really addressed any of those that. But I'm not saying that that's not possible. It can.
Okay.
But I can tell you one thing that isn't possible,
Mm-hmm.
and that is to get one of those balloons one in polar orbit. Now a polar orbit. Let me explain what
You're
a polar orbit.
Go ahead. I'm
Yeah.
sorry. You cut out for a second. Go
Okay.
ahead.
Sorry. So a polar orbit. I'll explain that. It starts again from our east coast, but instead of going towards Indonesia, the polar orbit goes up and then over the south, almost at the South Pole, a few degrees off the South Pole, and then comes back around. Now it keeps going around in that trajectory. It doesn't change. It goes in that trajectory, and the reason that it needs to do that is because the Earth is spinning around it. So the satellite gets to see every single bit of the Earth at some stage. As the Earth is spinning, the satellite's going around the same orbit.
Mm-hmm.
So you can picture that it's going to see the entire Earth at some stage. Now, these are typical satellites that are used by the military for spying and other military things that they do.
Yep.
And, obviously I'm not at liberty to disclose what the military does. But these satellites are essentially for military purposes. Okay, they call Earth orbit satellites. The ones the other ones which are quite benign, the ones that you actually when I say military, I also mean GPS. Okay, don't
Mm-hmm.
all
Mm-hmm.
right.
Mm-hmm.
So the satellites that are benign that we like to see are those like television. They have to stay in the same place all the time. So the satellite that you're getting your television from, if you're using satellite TV, is coming from exactly the same satellite. It stays there, and the reason it stays there is because it follows the Earth around.
Um, may I address this? Because
Sure,
I do have an answer for that.
sure.
Well, actually, not an answer. I just have a note to make about
Okay,
that.
yeah,
So,
yeah, go for it.
so this very same polar orbiting satellite system that you spoke of is actually the same system that they use to create the blue marble. Are you familiar with the blue marble imagery
Yes.
from? Yeah, Rick, was it Rick Simmons? He took the pick stitch images from this
Mm-hmm.
quote unquote satellite to
Mm-hmm.
create or project a globe. Um, Now, some would say that's good enough to prove that the globe exists, but I can say that you can literally have multiple launches or multiple planes or multiple balloons. Like I said, NASA is launching about 1,000 balloons a day.
Mm-hmm.
So
Okay,
they're
I
launching
can't.
these balloons, and they can take this information and they can literally do the exact same thing. So what I'm trying to at least hint towards you is that a lot of these answers that I feel that do support and back up your understandings
Mm-hmm.
also can be used in contradictory sort of form once you realize the origin and the methods that are used. So I understand you can't know everything. You have your hands full. You're a rocket scientist. You're doing real math, real science. You're calculating things. You're making sure things are safe and accurate. and that
Mm.
that takes a lot of time. So how can you actually go out and do the groundwork research to prove or disprove this model that you are actually living by? The fact that it is functional doesn't prove its existence. The function can
Uh,
just can merely be a ruse to keep the majority of the population under the assumption that it is real. I mean, it doesn't really it it's not impossible for any of this to be a reality. And then also, I want to touch one more thing. You did mention
mhm.
earlier, and I want to make sure nothing is lost. You did mention earlier on how, with both models, with the ball Earth model, the higher you go, the farther you're going to see. And I would argue with you and say that actually on a flat Earth model, it works exactly the same way due to perspective and how perspective works. Because when you're working with perspective, like for instance, like if you were looking down a hallway and you had a camera close to the ground of that hallway, and if you were to raise the camera up while you're looking down that narrow hallway, what you will see is further and further carpet, like, or more land, or however you have it.
I understand. Yeah.
You will get exactly the same effect. As a matter of fact, the only effect that you wouldn't get, so on a globe model, if you're the higher you go, the horizon should fall. It shouldn't fall that greatly, but it should be recognizable at certain altitudes up to 80,000 to 120,000 feet. And
Oh,
yet,
okay.
with a flat Earth model, if the Earth is indeed flat and everything is on the same plane, the higher up you go, the horizon will actually kind of stay fixed. The same way if you're looking down that hallway and you raise up, the end of the hallway is still at the same point in the center of the camera's focal lens.
Okay.
But what you're seeing is
Right.
more land, appear
Okay.
below it.
All
So,
right. Let me give me a chance.
sure,
Give me a chance to speak to a couple of those things. All right.
of course,
I want to get. I want to track back to where we are talking about the satellites in a polar orbit. Okay.
okay, sure,
And then and also at the same time address this idea that that you think that there's a possibility that that the Earth might be something different from what we think it is.
sure,
Now, I rely on the fact that the Earth is a sphere in order to get a satellite into polar orbit. I rely on that on its sphere in order to get a satellite into geosynchronous orbit. So it's not as though I put a satellite up there and hope for the best. Long before the satellite's gone up there, I have already calculated how far I'm going to take it. I already know exactly what I'm going to do about it. Now I know, for instance, if I'm using Kepler's laws in orbital mechanics to do that, for instance, r cubed over t squared, which is a constant,
yep,
and it's got to do with how far it is away, is how many times it will go around the orbit, how long it will take to go around the orbit. Okay, so in other words, the further away it is, the slower that satellite's actually going to go. Okay, so it'll take a longer time for it to get around because t squared increases. All right, so I can't actually get any of that to work unless the Earth is a sphere. It's impossible for me to get that to work, and I do get it to work. For instance, let me give you some for instances. Okay.
okay, sure,
Now, this satellite that I'm talking about in geostationary orbit, that's 36,000 kilometers above the Earth, is designed to look at a particular spot. Let's say, for instance, it's not our satellite, like, for instance, the Himawari 8 is not our satellite. We have other geostationary satellites, and some of which I can't speak about because they're military, okay? But a geostationary satellite like the Himawari 8 looks over the entire Pacific Ocean. And in particular, the people who pay money for that particular for space on that satellite is my own government, the Australian government. The Bureau of Meteorology, our Bureau of Meteorology, pays the Japanese government for the privilege of using the Himawari 8 so that we can work out what our weather is. Now, we're a country full of bushfires, full of things like that. We completely and utterly rely on the images from that satellite, which comes every 10 minutes, by the way, on the dot, and correlates with all of the groundwork that we've done. So we do have weather balloons. We do have ground stations, and they correlate what we see from the satellite. The satellite says, right, go and find that fire over there. Go and look for this particular thing over there. And it happens that it is there. So it's in real time.
Sure.
The Himawari 8 is so precise, it can tell us exactly where daylight's going to be, is going to follow the daylight around perfectly around the entire Pacific.
Hmm.
So it's actually an amazing thing to watch, and I'd encourage people to look through to look at it. Now, so if I rely on all of these things for this absolute precision, okay, we're talking about me being in charge of $200 or $300 million at a time. Okay, that might be a cheap one. I have been in charge of $500 or $600 million worth of rockets and satellites. Okay. Now, we're not doing this. We don't do this kind of thing, once in a blue moon, once every 5 years, or we do one of these every month.
Hmm.
In May, I'm actually here in April now, to work on the 2 satellite launches that are going to happen in May. That's C60, that's C47 and C48 polar launches that are happening just in May. We do these, so there'd be at least 15, 16 launches a year. That's just with us. Then there's the space, the ESA and the Japanese and the Chinese. They all do their own. And then we've got, SpaceX and other private companies that are actually doing their own.
Sure.
Rocket launches are so common these days, nobody cares anymore. But we used to get people lining up to watch these things. Now no one cares. No one gives a damn. Probably they don't give a damn in Florida anymore. Maybe Red's Rhetoric's the only one who goes to watch them.
So
Okay.
I would love to address some of the things you said, if that's okay.
Sure. By all
Okay.
means.
So you said, um, the system is so complex, it's so complicated. How could it be wrong? I mean, you got data coming from, live satellites in real time where you can see this and that, and you got
Mm-hmm.
your all the money, and the money that's being poured into these projects just to make
Yep.
these things happen. You got invested
Yep.
interest from all sides, all a part of the system, and so how can it be fake, right? Like, how can it not be real? Well, this is the problem with this. This is the problem because, I mean, if we're honest with ourselves now, and we said that something like that would be an impossible feat, or it'd be too complicated, or too time consuming, or too expensive to pull off, we have to
Mm-hmm.
be realistic. We have to understand where we're at in this day and age with the technology we have and what can be done. I mean, I don't know if you've played video games, but the simulations in video games, you can
Yes.
you can
They're
correspond with people
incredible.
across the world in real time and
Yep.
get information, and it's all fake. It's all convoluted and created from someone's mind. And yet,
And use
and
the
and yet,
satellites.
exactly, and yet you can have the same data, and you can have that data, that fake game, tuned into the Project Loon satellites and high
Totally.
altitude launches and all these things. So we have complex systems, but complex systems don't make things real. Complex systems are just that. They're just complex systems. There's just a lot of people, a lot of money involved. Now, if we were to
Yeah.
look at, like, let's say NASA, where they're making, $52 million a day, you
Mm-hmm.
know, one can easily understand that every space organization, they may not be equally funded, they may not be of the same stature, but they all have a very large budget, a large amount of money, a large amount of resources to make sure everything moves smoothly. Now, what people don't realize is they say, oh, well, you got different companies out there doing different things. You got like SpaceX and RASA and NASA, and they're all doing their own thing, so we say, right? But I would like to propose to you the origins of these so-called space industries. So I don't know if you're familiar with the origins of NASA. I'm sure you are, but
Yep.
um, red flags are being thrown all over the place when you have a literal cartoonist and a Nazi scientist basically being the forefathers of what we know today as NASA. Now, to me, that's like red flags all over the place. I mean, you don't need a cartoonist to start a scientific organization.
Uh,
You don't need any you don't need a Nazi scientist to start a scientific organization. You know what I'm
can I
saying?
try? Can I just speak to that for a second?
Sure.
Okay, all right. So human beings come in all different colors and all different attitudes towards life and towards each other. Now let's have a look at the. So you're obviously talking about Van Braun,
Yep. Yep.
who's the space, who's a rocket scientist.
Yep.
And mind you, he wasn't on his own. There were other
There
Germans
were
as
others.
well.
Yeah. Yeah. It was
And
the
and
project
and
paperclip.
Von Braun didn't do the work. He was standing on the shoulders of many other German scientists who had nothing to do with the actual V rocket. In other words, they were the chemists who put together the fuels. They were the physicists who worked out what the trajectories would be, who worked out how much fuel would be needed to burn. There's a whole lot of people who worked in the background doing other things, which the rocket scientists used. So we scientists don't work in isolation. When we do work, other people use our work. I use other people's work. I stand on their shoulders and people stand on mine. Okay, so whether somebody is a Nazi, whatever philosophy they hold, has nothing to do with their intelligence. Okay, that's got to do with their moral compass. Now, whether Von Braun was a bad Nazi or whatever, I've got no idea. I don't know. I don't know that person, and obviously the Americans thought he was useful enough to bring him across to America, and other scientists like Albert Einstein, for instance, who was also German scientist, and there were a few others. Okay, so he wasn't on his own. There's Planck and Niels Bohr and quite a few other scientists who came from Europe who really made the American science industry what it is today.
Well,
Uh, but just because these people might have been sympathizers, and Albert Einstein was not, just because these people might have been sympathizers of the Nazi regime does not mean that they didn't have the wherewithal to do this. But actually, I have one question for you.
oh yes,
Uh,
please.
okay.
Yeah.
So my question is this: why do you think that we would have any difficulty with making something like a rocket going to space? Why, for instance, it would be preposterous to think that I would have my hand in having a rocket um, take off from Chennai only to land in the sea. I don't know where, maybe in the Java Sea or something like that. Why $600 million worth of stuff on that? First of all, we're not the same as NASA, because we don't rely on our money comes from our customers. Okay, so it's not as though we're waiting for money from Indian taxpayers. All right, we make our money by launching satellites. That's our business. We're in the space business. Okay, just like SpaceX, they're not a charity. They're there to make money. They launch satellites in order to make money. In fact, they launched one of ours, I think, about 2 months ago. So we weren't ready, and so we had to give our satellite to SpaceX because the customer wanted it. So people pay us to do this. We're a business. We get money. We don't get money from taxpayers like NASA does. But NASA, of course, doesn't just do rockets. NASA is responsible for practically all of your science. The major science organization in the United States, and responsible for so many different areas of research, especially in the aeronautical area. So anything that's done by Boeing, by by McDonnell Douglas, by you name it.
Yeah.
These people use NASA for their research. NASA has test pilots. So, what as a
Yes.
scientist, I look at that and I think, my gosh, you Americans, you really are, you really are number one in technology, and yet half of you are not even proud of how good you are. You know, how about being proud of yourself? You guys are
Yeah.
awesome. You know,
So
I mean, if we want to learn something, we go off to MIT. I mean, for goodness sake, how about you being proud of what you can do?
true.
You
So
know,
I would love to answer that question that you gave
sure.
me. So you're saying that it's just as easy to go to space. So why not just do it? Like you're obviously launching into space in your eyes, right? So, but
Yeah.
I'll tell you, space is fake. Space does not exist. Space is a hoax. There is no space. So if there is no space, there are no launches. That's why you can't. That's why they have to lie. They have to lie because there is no space, and I'll tell you why.
Who's they?
They
Who's they?
well,
Who's
let's
they?
okay. Let's say controllers. Okay, we live under government rule, right? And then those government rule that group of governments they all work together, right? Where they call themselves the United Nations, right? And then the United Nations they have their rulers, they have their financial backers and their financiers. So those guys are in charge, right? So who's in charge of those guys? I don't know. But the point is they are the supremacy of the system. So we have to understand if there is some sort of supremacy of the system that knows that space is fake, they're going to make sure that there's a beautiful industry out there to allude to the fact of the existence of space. And I'll tell you my opinion. It's because they're hiding God. A lot of people will disagree with that. That's on them. But I see it as the perfect opportunity and the perfect means to hide the fact that you live within, you know, something that is not explained by science today. Now, let me go back to why I think space is fake, because I'm sure you have a lot of
Okay.
questions about that.
I'll certainly be talking about that. Yeah.
Cool.
Okay.
So this is why I believe space to be fake.
Sure.
I've seen enough evidence to suggest this. So, um, are you familiar with like the high altitude balloon launches, like to 120,000 feet and such? Or have
Of course.
you looked at some of these? Okay, so first off, you have when you have cameras on these that are not fisheye lens or or GoPros or anything like that, the horizon is completely flat, 360 degrees all the way around, which is to me an impossibility at that altitude. But secondly, you also have the same phenomenal, the same occurrence. Hold on, I think we actually dropped for a second. I think we're back on. We had the same. Uh, we also have weird situations about these high altitude launches where there seems to be some sort of limit, there's some sort of barrier, something is happening at these altitudes. There have been rocket launches, like the Go Fast rocket launch, where it was literally spinning out of control, traveling at increasing speeds, and literally just comes to a dead stop and begins to fall. You have balloons that are launched from such great heights that
You know
reach.
why that happened, don't you? Do you
I,
know why that happens? That I'm fully aware of that happens and have experience with that.
okay,
So do you
okay.
know why that happens? It's
I
because a balloon reaches a certain altitude and then explodes.
Okay, that's what I was going to
That,
say next. The balloons also do that as well. Yes.
they do explode.
You got rockets doing it. You got
They
balloons
don't
doing
hit
it.
anything;
You
they
remember
explode.
the? Are you familiar with the Virgin Galactic test flight that failed?
Yes,
Okay.
yes.
Did you also hear about the fact that it came to an abrupt stop, literally exploded and fell to the ground? All right.
No,
Like didn't explode like in
that's
a
not
fiery
my way.
crash, but it literally struck. A lot of people believe it struck something and began to fall uncontrollably. You have countless testimonies of people doing launches, different things like that actually prove that there's a surface. And then there's also science. There's not science. There's observations that actually back this up. For instance, what about sprites? Are you familiar with sprites? where you have electrical phenomenon disturbances that are actually going off high in their atmosphere that seem to be projecting off a surface. When they explode, they seem to be stretching or dripping down from a surface. And then you also have other issues and stuff like that. Like for instance, lightning and thunder. When you hear the sound of thunder, all right, it's an echo. It's an echoing sound. Echoes can't you can't get a repetitive echo off of one surface. It can only echo once. To echo, it has to bounce back and forth. If
And
there's
there's
no
plenty to bounce off.
the
There's plenty to bounce off. There's
the
atmosphere.
firmament, the
There's clouds.
the clouds,
There's clouds.
the
How
sound
about
is
that?
bouncing off clouds. Okay,
Try to think of that. Try to think of that from a scientist's point of view. Okay, all
sure.
right. The, First of all, we try to work out what is the simplest explanation, not the most difficult explanation.
Yeah.
Can you imagine how many other things we would have to explain if there was such a thing as a firmament? I mean, how mind-boggling explanations and things that just couldn't, that where would a comet come from? Where would it hide underneath this dome? Where would a comet? Every year, every 76 years, we can predict on the dot when Halley's comet's going to turn up.
Oh yeah, like
How
clockwork.
do we know that? And
Yeah.
where was it? Where was it underneath the dome hiding all this time? Maybe the Russians were looking after it.
No, no. I think you're asking good questions, and there are good answers for these too.
I mean, well,
So
I'd
so
like to hear
first of
a
all,
good answer for that one.
First of all, the comets thing, I think, also really lends more credence to the enclosed system theory because if we were living on a ball spinning relentlessly throughout space, you would have comets coming up from the horizon straight up. You would have comets, streaking from all sorts of directions. You would have all sorts of phenomena like that, but yet we don't. You know what we get? We get comets always coming down. They
Why
always
would we? Why,
they
why would you think that? Why,
why
why should there be?
why should they not come down, or why
No,
would
no.
they?
Why should there be comets streaking all over the sky all the time? Why? Why?
Well, there is no up and down in space. Am I right? So how do comets know which way is
No,
down?
no, it's they don't need to know what's going. But you just said to me we should see comets going whizzing past all the time.
Upward, going
Is that
from
what
the
you?
horizon straight up like a rocket. But we don't see
But
that
why
because
would
like
they?
the same comet that's coming down that misses the Earth is going up on the other side of the Earth. Am I right? So why isn't the other side of the Earth witnessing these events?
The
This is what I'm
comet's doing
saying.
an ellipse around the sun, not around the Earth.
No, I'm saying whenever there's close encounters with the Earth and you have comets that fall, and I get it, that some are being pulled down to the Earth, but some actually miss us.
Sorry, meteorites, yeah.
Yeah, some meteorites, some comets, they actually miss, and when they do, hopefully all comets miss, but you know what I'm saying? They miss, and when they do, and yet we never see them streaking upward in the sky. So we only get the
Oh,
phenomenon
yes.
of them sort of coming down at an angle, just as if they are literally coming from a surface or some sort of
Is,
area.
is, is that not a clue about the rockets and orbits and how that works? Can you not look up and see, for instance, the ISS whizzing past the moon, and you're thinking, where on earth is that going, and where does it come from, and why doesn't it stop? And how does that thing looking like an H stay up there? I
Now,
mean, why
first of all,
why aren't those questions you're asking yourself?
we're going okay. I can answer that, but I just want to make sure that we don't stray too far from the path here. But we are definitely
Yeah.
leading into
There,
straw man
there's
territory.
other things I want to get back to because I still want to get back to God, by the way.
Yes, yes, and I want to just point out that first of all, what we see in the
Hmm.
sky doesn't prove anything. It may not prove a flat Earth. It may not prove a round Earth. Uh, Physically speaking, Earth should prove Earth. Like we should be able to measure, observe, and see the Earth as a curved surface, and we don't. You know what I'm saying?
Yes, we do. Yeah, I'm sorry, but we do.
And that's where we're going to disagree because there is no evidence
We,
of
we,
this.
we do. Yes, there's plenty of evidence.
The evidence is
The,
the
the,
data
the,
that you said
no,
that
no,
exists,
no, no, no.
which
The
that's
evidence
nothing.
is my camera. When I deploy a satellite out of once those fairings are gone, the satellites are sitting right there prone. They spring loaded. So we release the spring that comes from us down at Earth. We release the spring, and that flicks the satellite into its orbit. Okay. At that point, we're looking at the satellite because we have a camera right behind them, looking
Hmm.
at them as they are being deployed. We can actually see them leave. That's essential for us that that happens. We see that, and guess what that blue stuff is over to the left or over to the right when that's happening? Well, that's our beautiful planet. Okay, and guess what? Sorry, but it's curved.
Oh,
It
you.
is.
Oh,
It
those
is
images
this
they
way.
show us. You're talking about. Okay, I get what you're saying.
No, 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 no. Forget your images. I'm talking about what I see.
Okay.
I'm talking about my own personal experience, not what
Right,
someone's dragged from
but
YouTube.
not your eyes. Not you were not on these rockets. You're not injecting
I'm the one.
yourself into
I'm the one who
space.
inspected those cameras.
I get you inspect the cameras, but it's a camera. Like you're literally getting a video
What do you
feed.
expect from a camera? Aren't we? Can I see you and you see me? Is this not a camera?
Yeah. But
Don't
does
you,
does this camera prove my
that
physical
little bloke over
existence?
there can't to believe that what I'm seeing about you.
I mean, does this
Now
camera really?
you wearing a t-shirt saying nope.
I've seen Godzilla at the movies. Does that mean Godzilla's real? I've
Well,
seen
I'm
I've seen
really, I'm,
Gravity the movie. Does that mean they were really in
hey,
space?
no, but hey, I'm entitled to believe that you are that person sitting over there, and am I not?
I mean, that's a good
Would
point.
would that be an
You're
outrageous
entitled to
belief?
that. Yeah.
If I thought that if I believed that you were there, that person talking to me, and you seem to be moving and being animated in a way that I'd expect that to be, and I'm looking at your shirt and it says nope, and sometimes you move backwards, I can see it, sometimes I can't, and I'm thinking, well, okay, that cool dude
Okay.
over there,
So
I'm looking at him through a camera, and I'm entitled to believe this information that I'm getting across from my computer over here. You're looking at me. You can see that I'm wearing my glasses, my dark glasses, and you can see that I'm an old dude.
and entitled to belief is exactly what we're talking about here. This is what I'm saying
Well,
is that
it's more
belief
it's more
is
than just belief, though. It's belief based on very very compelling evidence. I have very compelling evidence that that's actually you. All
yes.
right. I I,
I
I think
understand that.
I think it would be miles too freaky for you to be moving your mouth in unison with your
No, I mean
voice.
we can
Or
both
you being someone
definitely
else.
agree that we can be compelled to believe things. We can easily draw the lines to see that
So so
something
this.
seems the way it
All
seems.
right.
I get that. I do respect that.
Do,
But
do
what
you
I'm
respect that this camera might be the one that's on the spaceship? That's on the rocket. Do you agree that this very camera
I
that we talk about, this very technology that we currently using, you and I now, is actually on the rocket? It's this very technology that we're using to look at our own satellite leave the rocket. We have every reason to know that this camera is linked to us. It does what we want it to do.
every
It
reason.
does
Yes.
exactly. It's
I
it's,
I
it's
understand
we're
that.
not in a magic world. It's a reality. We don't. I can't. Oh wow! How did that camera just move by itself? Oh no! I did it. Look, watch this joystick. Bang! There it goes. Bang! There it goes.
But
No, that didn't
okay.
happen by accident.
All right, hold on, Phil. I love you, man. So everything you're saying can be refuted. It can be literally refuted on every level. You could play a video game and control the characters in the video game. Does that mean that those characters are really actually in that world or
All right.
someplace else?
Let me
You
ask you.
could see what I'm. Let me just get to this point. So there, a lot of what you are taking in as truth. Of course, you have no reason to believe otherwise. Of course, it makes perfect logical sense. Of course, it matches with the data and the understandings that you already have. I
Yeah.
understand that, and I am not trying to refute that per se. What I'm
Yeah.
trying to say is that if we are to say that that is the absolute absolute, are we telling the truth? Are we being honest with ourselves and saying that this is absolute, unrefutable evidence that actually proves that these satellites are being inserted into our orbit and they're flying around? The fact that you're getting data from multiple sources that agree with themselves doesn't necessarily make something a fact, doesn't necessarily make something legitimate. What makes it legitimate is who is buying it, what you believe, how you interpret that information. Now, we can all interpret an information if it's programmed for us to interpret it in a certain way. And that's what I'm trying to relate to you is that you may be correct on everything that you wholeheartedly are standing upon, but what I'm saying is that there is always a shadow of doubt, and if you are to take this in as the absolute absolute, that is some dangerous ground because you are allowing yourself to limit your absoluteness with just data that agrees with what you see. Now, what I'm saying is that there's a lot of data you haven't, and I understand you've read a lot of the points of flat earthers, but flat earthers are flat earthers not because there's some good points out there. It's because there are a limitless amount of points that actually support the flat earth. I say
No,
limitless. Literally every day, proofs are coming up. Things are
no,
coming up that
sorry,
are
Steve. They miss.
contradicting.
No, they're misunderstandings. They're not. They're not. They're not proofs. Sorry.
Maybe,
In
maybe,
fact,
maybe that's a perspective. I
I've
get
never.
it.
I've never heard of one that's not a misunderstanding. Okay.
Okay,
Now, let's just keep on the on this topic, because this is what I do. I personally, this is a two human beings talking to each other. Okay.
correct.
I have no reason to want you to believe something other than what I think is a fact. Okay, I've got no reason for wanting you to do that. All right, I'm just simply telling you this is the job I do. Okay, I am the guy who actually takes that satellite from that transfer orbit and puts it in that permanent orbit. Okay, I rely on everything that's I rely on all of the work that's done by people who came before me, and the work that I have done myself, in order to get that kind of precision. Okay, now this is happening. Now, one of the questions that I've never been able to get someone to answer, and perhaps you can help me with this
Sure.
one, okay, and that
Okay.
is when a country, a small country, pays me. When I say pay me, I'm talking about our organisation.
Sure.
Pays our organisation, say, $450 million. Okay, that's to put in to launch a bunch of satellites. We have a contract for $450 million. Might involve 3 satellites or 4 satellites, and we might do it over 2 payloads or 1 payload, depending on how we can structure it. Okay. Now, these people that have these satellites, they need them for a reason. They don't want satellites up there just for the sake of making some I don't know, throwing things up in the sky for nothing. They
Right.
actually want them to do something. Okay, so they may want them for their military, or they may want them for Earth observation, or they may want them for their local television. Whatever they want them for, they need them for something.
Hmm.
So once I have these things in their permanent orbit, where they're doing what they're supposed to do, I now had to hand over these controls to the people who own these satellites.
Hmm.
I
Yes.
don't own them. I'm just getting paid to put them up there.
Yep.
Okay, other people own them. So now I've got to hand these over to those people. So I've got their team of people saying, "Okay, all right, now guys, let's see you do that by yourself. You've got to monitor this. You've got to monitor this parameter, that parameter, that parameter, that parameter, that parameter, all of those sort of things to make sure that your satellite works. And this is how you change it if it's not." So I teach them this is how all of these things work. Then
You
I
teach
hand it to
them.
them, and they go back to their own country and do this.
Okay.
Do you think I would? How could I tell them? Oh, how can this be a pretend thing if those people are going back monitoring their own satellite? Is it possible? Maybe I dump their satellites into the sea, and then now pretending that they're looking at satellites and they're not. Are we lying to all these countries in the Pacific Ocean? All these little countries. Oh, you know what? We didn't actually put those satellites up there. We're just lying to you. That's preposterous. That doesn't make any kind of sense at all. They pay us a lot of money to put those things up there, and they need them. They put them up there for a very good reason,
Actually makes
and they,
perfect
and they
sense.
use them.
Well, it
Okay,
it actually makes perfect sense why they
yeah.
would lie and why they would scam all these
Why?
countries.
No,
Yeah,
why?
I mean, like you said.
But
Okay, so
seriously, how are they working out what the? How does Australia work out what the weather is if
how
it's not
much
that satellite
how
up
much
there?
money is spent on, let's say, like one satellite, just one actual device that they put in the rocket?
Well, if a small satellite can cost 40-50 million dollars,
Are there
sixty
people
million
who
dollars.
are there shareholders involved with these projects?
Usually private companies,
Yeah.
yes.
So there's profit to be made.
the people who own those satellites have paid a lot of money to have them up there.
Sure, sure. I mean, McDonald's pays a lot of money to put out ads, but yeah, they got a profit to be made, of course. So they're gonna make that profit. So
Yeah.
what I'm saying is that I understand where you're coming from, man. Like, dude, like I said, I love you. I love you already. I want to be friends forever. I want us to stay in contact after this conversation. I want us to have more conversations. But what I'm saying is, I mean, there's profit. There's money involved. I mean, you're saying that there's no reason for them to be doing this, but there's profit. I
Okay.
mean,
Let's get back to this. There's another question I wanted to ask you about.
okay, okay,
You brought up this idea about trying to hide God.
okay.
I've got some news for you. The people I work over here, there's about 3,000 of them actually altogether. To a person, they would have at least 1,000 gods each. Trust me, there's nobody trying to hide any god. They got their 1,000 gods. They still put satellites in space, and they're still very proud of their government. And they have about 1,000 gods apiece.
Well, the God
Okay?
that I'm referring to,
God is not an issue. God is not an issue for them. Okay, so they're not trying to hide God. That's for sure. Okay, they're not trying to hide any of their 1,000 gods.
we
Okay,
can
and
disagree.
and by the way, they have this. They have the creation stories and all that are exactly the same as Christians, and they're not trying to hide them.
Yeah, and in that,
They
cre-
accept the fact. See, they
sorry, go
have a
ahead.
saying. They have a saying, just like you, like if you like Westerns do or Christians do in the Bible, that says something about God gives you these talents, okay, and He expects you to use them. And one of these talents is your intelligence. So there's no God up there saying, don't use your intelligence. Okay? There's absolutely no reason in this day and age why we could not build a rocket. There's no reason why we couldn't put a rocket in space. There's no reason why we couldn't put a satellite in space. There's none, absolutely none at all.
So
Now this brings me to the other point that you made, because you said space is fake. So I'd like to address that if I may.
sure, sure, sure. Can I really quickly just address
Sure.
the God argument thing? Because I
Okay.
know there's a lot of flat earthers that may not agree with me on this, and that's fine. But I do want to make my case accordingly. Um,
Okay.
and that is, you did mention like, okay, so are they hiding all these gods, and then they all have the same story? And I just want
Well,
to
no,
point
they're not
out
hiding. That's the point.
similar. So I just wanted to point out that a lot of these cultures also have a very similar creation story. And
Yes, they do.
in that creation story, what seems to be the ongoing theme is that the earth is actually flat and the firmament is stretched above the earth and the sun, moon and stars are set within that system. So that's what I just wanted to point out first, before we go any
I
further.
understand.
Yeah.
I'm.
And that's what I meant by hiding God, because they're literally
I
hiding the creation story.
don't admit I'd met an Indian who would say that that is a literal fact. Okay, so I doubt anyone would say that,
Okay.
and especially no one I work with anyway. Okay, obviously. Now, but let me address this issue of space.
Please do.
Okay,
Yes.
all right. Okay, I think what's wrong in this whole flat Earth argument, and certainly from the people who are also let's call it the other side of the fence, all right, for whatever better terminology. So let's have a look at what space actually is. Okay, let's have a look at the atmosphere, what it is at 103 kilopascals at the Earth's surface. Okay, we have atmosphere. About look, I don't want to bore this thing with huge numbers, but I could actually tell you how many molecules there are per cubic meter at the Earth's surface. All right, say on an average temperature of say about 20 degrees. Okay, 20 degrees C. I'm sorry, I can't translate that into Fahrenheit
That's fine.
on top of my head. Okay, all right. So at 101.3 kilopascals, as you go up further and further and further, this gets less and less and less.
Hmm.
And it's the reason that it gets less and less is because there are fewer molecules per cubic meter up there. Okay, can we accept that?
Sure.
All
100%.
right.
Yep.
Now, at some stage, you've got to realize what stops it from continuing to do that. Now, let's just say, now at this stage, I want you to put the dome away at the moment. Okay,
Okay.
so we're not going to talk about the dome. We'll come back to that. Okay,
Sure.
because I certainly have a lot to say about that.
Okay.
But however, let's say, for instance, so now this thinning of the atmosphere goes further and further up as you go. If you're at the top of Mount Everest, you definitely will need something to breathe with.
Mm-hmm. I've been on a
Okay, there's
mountain,
no
so I know
question
that's
about that.
true. Yes.
Okay, and if you go and if you're in an aeroplane at 40,000, it's 40,000 feet, you most certainly would need to breathe at that stage. There's actually an aeroplane at around about 35,000 feet that killed everybody on board simply because they had there was some sort of decompression,
Mm-hmm.
and the cabin actually everybody on board died. Okay, a ghost plane eventually crashed. It was a Greek plane. Okay, so we know now that the atmosphere gets thinner and thinner and thinner. Well, now try to imagine this as it gets thinner and thinner until there's practically none left. Now that's a long, long, long way away before it gets to the stage where there's practically none left. Well, they, for want of a better word, they call it a vacuum.
Okay.
You
Now
know
we're
why they
now
call
we're
it
getting
a
into
vacuum?
my territory. Go ahead.
They call it a vacuum because it's got very few particles of gas. Not because it has a not because there's a generic word for some vacuum where you take out all of the gas from some container and then you call that a vacuum.
Well, vacuum
Okay,
should be
a
a
vacuum is a
negative pressure
generic.
system.
No, it's not a negative pressure. It's just no pressure.
Zero pressure. Yeah, that's what I meant. Like, as in no
It's not
pressure.
negative.
Yeah.
It's not negative. It's just no.
Yes.
Okay, or very, very little. In fact, no is not even a good answer for it. It's very, very little. Okay,
Yes.
and that can extend far. So there's so even as far as the moon would go, there would be at least 100 molecules per cubic meter still of
Sure.
gases. So it's not as though it stops. There isn't a place where bang, there's no atmosphere and suddenly there's atmosphere and then suddenly there's none. There isn't anything like that. Okay, it goes
Right.
on and on and on. We just had some evidence now that
Which.
that,
Go
that
ahead.
there's some gas even as far as the moon
Yeah, I know. They're saying our atmosphere stretches
and
to the moon
beyond
now.
and beyond the moon.
Yeah.
Science. The wonderful thing about science is we keep learning stuff every day. Every day is an exciting day for us
A
because
lot of
every day,
new.
even by 45 years, I still learn stuff every day. It's a wonderful thing to be a scientist.
Sorry, I didn't want to cut you off while you were talking, but
That's
so I,
okay.
I want to address this, what they call the pressure gradient of Earth
Yes,
and
please
whatnot.
go for it. Go
Yes.
for it.
Okay. So we know on this Earth,
Hmm.
science has shown us that you can't have a positive pressure system and no pressure system. Remove the containing wall between the two and not equalize. We know that that cannot be recreated on Earth. Though that's what they say is, there's a gradient and eventually
No,
the
they
pressure
don't say
lessens,
that.
lessens. But what I'm saying is we know on Earth that you can't have uh, a pressure gradient system enclosed and
Hmm.
zero pressure, like put it in a no air, no nothing is left, all right?
Of
And
course.
crack a hole in it, and that gradient is going to diffuse. It is going to expand and just blow into that zone. And what I'm saying is that you cannot have a pressurized system sitting next to space, which has no pressure, or a zero pressure system, and not equalize at some point in time. Because it doesn't make sense. The only way you can explain that in the scientific terms is with gravity. You would need gravity, some sort of force to draw the pressure downward, which doesn't make sense and it cannot be
No, no,
reproduced.
no, no, no. So stop saying things don't make sense. Okay.
Okay, I'm
Let me.
sorry. But let me finish my statement. So
Yep. Sure.
So, like for instance, I can have an aerosol can, right? And in
Hmm.
that aerosol can, I have particles. I
Hmm.
have I have paint. All right, I
Hmm.
have gases. I can
Sure.
set that can down for a week,
Hmm.
2 weeks, 3 weeks, and what's going to happen? What's going to happen to all the particles and pressure in that can? Is it going to be the same everywhere in that can? No. All the
Yes, it will.
heavier, no, all the
No, no,
heavier,
no, no, no.
the
The
denser
solids,
particles.
the solids
Right.
might very
I'm
well
talking about the particles,
stick to
not
the bottom. No,
not
no, 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 no.
the vacuum
Forget about
itself.
the bottom.
But
We're
what I'm
talking about the
saying is
gas.
the particles within those gases, as
No, they
soon as
won't see.
you puncture into that can, they're going to be violently tossed about within that
Of
can and
course,
make their way
of
outside
course,
the container, right?
of
Yet we
course.
have Earth, which has atmosphere, it has particles, it has liquids, it has, materials, and no containment around it whatsoever, and nothing is
No,
boiling and flying off the Earth.
no,
That's insane.
I'm sorry, but the only thing wrong with all of that is simply that whoever told you that is mistaken. There is no there is no part in space or between us and up there where there should be a barrier. Okay, it's not as though these. It's not like your can that you're describing.
Yeah, but when
It's
you
just
release
simply
containment
less
for
and less. Put it this. Let me ask you some questions, and then let's see if you can work that out. You understand that there's less molecules around Mount Everest than there is further down.
sure.
You agree with that?
Yep. The heavier
Why
particles will go down.
why don't they equalize?
Density and buoyancy.
Really? What's that? And why
Density and
shouldn't
buoyancy?
and why shouldn't density and buoyancy apply in space?
Yeah, why shouldn't it?
You agree that it doesn't that the air and above and below Mount Everest don't mix. You agree with that? Hmm?
Yeah.
Yeah, good. Okay. And you agree with even higher than that at 40,000, because Everest is 29,000 feet. At 40,000 feet, they mix even less.
Yeah, you'd have to literally shake up the earth like a spray can
Right. So why don't they mix?
because they're in a pressurized system and at
Why are
rest.
you expecting to mix over at 40,000? You're not expecting them not to mix at 40,000 feet, but you're expecting to mix at 120,000 feet,
Because they're
at
within a container.
120,000 miles.
Because they're
No, they're
within a
not.
container.
No,
The same reason why like
no,
you
no, no, no,
shake.
no, no, no. That's nonsense. You could have put it this way. Let me because you brought up this container. I need to address this issue about the dome. Okay.
Sure.
All right. Okay. Have you heard of Dalton's law? Okay, let me
I'm
explain to
Go
you.
ahead. I'm sorry.
For your listeners, I'll explain Dalton's law. Dalton's law it pretty much says this: if you have a container of gas, it will form an equilibrium. In other words, you cannot expect the container of gas to have a pressure gradient in it. The pressure will become equal to all walls.
Yes, the pressure
All
will,
gas.
but the
Yeah.
go ahead. I'm
What
sorry.
do you think pressure? Pressure is each individual particle bashing into each other and against the walls
Yep.
and against anything else. So if you're sitting in the middle of this, you feel pressure because particles are bashing into you.
Yeah.
Okay, that's you feeling the pressure. That's what pressure is. It's
The
particles bashing into you. Well,
the
when there's
relation.
less of
Go
them
ahead. I'm
to
sorry.
bash into you, you don't feel that pressure because you don't feel so much pressure because there's not so many particles bashing into you. Now, if you have a container, all of these form an equilibrium. Okay, we know this because we've tested this over and over again, and a law has been written about this.
Yes. The pressure forms an equilibrium.
Dalton's law.
Yes. Yes.
Okay, so pressure equalization is known.
Yeah,
If
in
there
a
was a
container.
dome,
Yes.
if there was a dome forming a container around the Earth and a sun with a surface temperature of 6,000 degrees, all of this gas would have been heated up. All of this gas would be at an equilibrium.
Good point.
What on earth would cool this gas down at some stage? Nothing.
Well,
Okay,
we actually haven't touched
this is
on
what
that,
makes
but
that dome.
I'm sorry. Go
That's what
ahead.
makes that dome practically well, not practically. It makes it totally impossible. So even if all of that stuff that I do
Hmm.
with the satellites, if all of that was, I don't know, some, or I can't even imagine. There's no words I could put on it. But let's just say that it was wrong. The dome could not be right. That in itself cannot be right. That it's much to put a rocket in space, to build a rocket that has fuel, that can go in space, that
Hold
can
on.
go up there,
Hold
that
on one
can
second. I'm
let us
sorry. It
is a
dropped
hell of
out.
a lot easier than trying to figure out how a dome could work.
Wait 1 second. It dropped out. All right. Let me just make sure you
Okay,
didn't cut off.
I can hear you though.
Okay. Oh no, the live stream. Yeah, it dropped
Oh,
out. Repeat what you just said the last 5 seconds. The
okay.
about the dome. Yeah.
Okay. So what I said was that it's much the probability that what I do is right, putting satellites in space and observing the Earth from that is a lot easier than you could ever be trying to figure out how you could get a dome to work over the Earth, especially with this business of the gas. That alone should get you asking yourself some serious questions about this because Dalton's law works. It will form an equilibrium. Why doesn't it? And you still haven't answered the question, why is it
It
that the
does.
air above above and below Mount Everest don't mix? And yet you expect them to mix
No.
if they're further than that.
What?
But you do. You said to me, how come we have the atmosphere
I'm sorry. Go
and,
ahead.
and space? You asked me that question. How come we have the atmosphere and space and they're not mixing? You asked me. You said, why are they not mixing?
Yes. Can I
I'm
answer these?
I'm asking you that question. Why are they not mixing?
Sure. Can I answer those?
Go
All right.
for it.
So, there are lots of evidences for this. Like, for instance, you can fill up a fish tank with, I forgot the type of gas. It's like a denser type of gas, the opposite of helium, I believe. Um, I may be wrong on this, but there are gases that exist.
I know all 92 elements, so
Okay,
I'm
that
happy for you to
that
come
are
up with one.
denser than air, and that will fall below air as air, oxygen and
Well, there's a lot.
other gases will rise. Yes.
Chlorine's denser than air. Anything
Yeah.
above 29 moles per
What I'm saying
grams
is,
denser than air.
that it is not an impossible. It's not an impossibility that gases will find their equilibrium, yes, but they'll settle at their density and buoyancy levels. So if something is less dense than the air itself, it's going to rise. That's why you have helium go up. You have oxygen come. Oxygen has a different weight to it, so obviously it's going to settle below it. Just like if I were to pour multiple liquids in a glass, and then you would have milk, oil, water, all these things. They will all find the level in which they operate at, and they will equalize at that level, which is exactly what you get on Earth. It's exactly
All
what you
right.
get on Earth.
Okay. All right.
Now,
Good. Good. I wish you were one of my students right now because that is a very good question. Okay. That is a very good question. Now, be very thankful, and if you do have a God for you to pray for, be very thankful to that God that you are wrong. Okay, because carbon dioxide is 44 grams per mole. Oxygen is only 32. O2 is only 32 grams per mole. Okay, oxygen itself is just 16 grams per mole. Nitrogen is just 14 grams per mole. And the carbon dioxide is 44 grams per mole.
mhm.
You want to be standing on your tippy toes to breathe? Because that's what you'd be doing.
Yeah, but we're also moving on the ground, and the air is being displaced, and
Yes, of
yeah,
course. That's beautiful. Because the heat that's happening on the ground, the sun is heating up the ground is heating up, trees are taking in the carbon dioxide, producing the oxygen, and all of this is giving us a beautiful mixture called air, which we all can breathe. Luckily that you're wrong and that those gases don't settle the way you think that they ought to. Okay, otherwise we would be having carbon dioxide at the bottom,
I sh-
actually methane a bit further up, oxygen nitrogen, and so on, and hydrogen and helium up near the top. This doesn't happen.
I should have been more
Okay, we get
specific
air
and
all
said
the way up.
undisturbed is what I meant. But I get what you're saying. I get what you're saying. So,
Okay.
we've touched on. Let's just real quickly kind of address everybody here. We've
Yeah,
touched
sure.
on a lot of things.
Yep.
We've both had some really good feedback. Hopefully, we can both.
We haven't done why does how does a rocket go into a vacuum? We haven't done
Yes,
that one.
yes, and actually we
Okay,
will do that right
someone did
now.
ask that question. Okay,
Yeah.
how does the rocket go into a vacuum?
Yes.
Okay, all right, beautiful question. Okay, all right. So obviously you've heard what the what everybody else says, and in a sense they're right. Okay, so Newton's third law of motion. Okay, which says that every action has an equal and opposite reaction. Now I want you to think about this. Think about a gun or a ballistic missile. Or do you know what a bazooka is? Do you
Oh
know
yeah.
what a bazooka is?
Mm-hmm.
Yeah. Okay. So you put it on your shoulder. It's
Yep.
like a tube, isn't it?
Sure.
Okay. And about halfway through that tube, or a bit further down from that tube, is there's a firing pin that fires this rocket, goes straight out of a bazooka.
Yes.
Do you get what I'm going with this?
Yeah, it's got something to push off of. Yes.
Oh, what's it got to push off with?
The bazooka itself.
No, it doesn't.
So
There's
the
nothing.
rocket is not pushing off
It's
the
just,
bazooka.
I asked you if you know what a bazooka is. You don't know that it's just a tube?
I guess I don't know what a bazooka is.
Okay. You push the rocket in from the back end.
Okay, got it.
Okay?
So
And
it's
you
like
push it in,
yeah, like you stick it in one end and it comes out the other.
and it comes out the other. How
Okay.
do you think it comes out? It's got nothing to push against.
The air, the atmosphere.
No, I don't think so. You think there's enough atmosphere in that little tube?
Um, there's air. Air goes everywhere,
No.
right? Permeates. So
Think about that. I mean, the thing about the flat Earth people is they're great at summarizing things in terms of what's possible and what's not possible. Now think about that. There's this tube with a tiny little bit of air in it. Okay, probably about 2.5 feet of air. Okay, all right, 2.5 feet of air. That's all it's got. And this bazooka, when you fire it, is going to fire a kilometer away.
yeah,
1,000 meters. It's going to go. Now you got to tell me how that happens with nothing to push against.
yes.
Now when you work that
Now
out,
we're talking.
that's how a rocket works.
All right, so let's touch this. Right, I have something to talk about that. Okay, so
Sure.
we all know how rockets work. They could be chemical, they can be fueled, they could there's plenty
Yeah.
of different styles of rockets. But we
Ours are liquid. With ours are liquid. UDMH and nitrogen tetroxide.
cool,
So
awesome.
okay,
So
the reason we use these two fuels is because that the oxygen is four oxygen atom, which make a fantastic oxidizer for this fuel. Okay?
beautiful. So let me get back to what I was saying. So are you familiar? I hate to throw YouTube channels in there, but I just want to illustrate an example here. So, are you
Go for it.
familiar with Cody's Lab? He's like a YouTube science channel, or whatever. Um,
Sorry.
okay, so he did an experiment because he had a lot of problems with flat earthers commenting to him
Yeah.
like, "Hey, what about this? What about that? Can you prove or
Yeah.
disprove this?" So he did a few experiments just to kind of see uh, what validity these concepts actually hold. And one of the experiments he did where he had basically a ignitable fluid, not fluid. Substance similar to like gunpowder, where if under direct heat, with a laser or whatever, it would ignite and create thrust. So he did the experiments in two ways. In one way, where he allowed air into he had basically a vacuum, but it was unsealed. So it was open to the air. The air can permeate and enter into the vacuum freely. And in that vacuum, he ignited with a laser the gunpowdery substance. And in that atmosphere, in that sort of environment, it did exactly what you expected to. It heated up, it burned, it even moved at the last second. A little bit of it just kind of shot out. So
Mhm.
perfect sense, right? So then he closes the vacuum and then takes out all the air, or at least most of it, not all of it, but
Well, that was
it,
pretty dumb.
yeah. So he removes the air from the vacuum. So now you
Yeah,
know, so now he's trying to ignite it with the laser, and guess what's happening? The
it's not going to work.
It's not working. It's not working.
Of course, it's not going to work because there's no
Yes,
pressure there.
yes. And then he did
It's got to have an initial pressure.
yes, yes, and that's what
Okay?
he did. He actually did.
It doesn't have to have a room full of pressure. It only
Sure.
needs to have a cup full of pressure.
Awesome. Yeah, and we're going to move on to that. Actually, I'm actually proving what you said to be right to some degree right now. So he took the experiment to the next level because people, that wasn't enough for people. So he went back and he did the experiment again. This time he made it a little bit more complex. He had a vacuum outside that was large enough to hold a spinning, basically a stake, and on that stake he had two rockets facing opposite directions, and he had an electrical igniter set into him. So when all he had to do is just hit a button, and then they would ignite, and the rocket should spin around, in a circle within that area. So when he first did it, he did it again just like last time, where he did the vacuum and then ignited them, and noticed that they actually weren't propelled. The fuel never ignited. What he then had to do, which is actually what you just said, it actually proves what you said is right. I'm not saying that what you said is wrong. Where he created a smaller container around that rocket that had air that was still, that hadn't been taken out of the chamber, but that was enclosed within its own container. So he had two containers. So he has one
But,
container which is a vacuum, and then he had a second container that
yep,
wasn't a vacuum,
yep,
and then he ignited it, and it actually worked. So it makes perfect sense, right? Now
of course.
here's where things get a little hairy, is
Yep,
that now I'm not saying that that doesn't work. I'm not saying that you can't get to a certain stage and then it shoots off and then it's going to go and it's going to make its orbit. Now let's get to the point where it's rectifying, correcting, adjusting, and changing orbits. All right.
mm-hmm.
So now it's already inserted. There's nothing to push off against. There's no container. There's no extra module to.
Doesn't need to push off anything, but yeah,
I get it. I
we'll
get it.
carry.
So now it's in a completely different scenario. So now
Yep,
we've removed the containment for it to push off of, and now it is sort of in this state. And somehow, some way, we have satellites up there, and some of them are using air for thrust, some of them are using gases, and all types of methods, and they're able to move and adjust and rotate
of course,
all
because
throughout the space.
none of us are trying to light it.
Right.
None of us are
I understand it, but
trying to light that gas.
I'm talking about thrust itself. The fact that these rockets can move is a marvelous feat within itself, because it would suggest that the space itself can be pushed off of, and that's where
No,
things get a
no, no, no,
little
no,
hairy, because
no,
I
no,
get
no, no.
that you can insert I get that you can
No,
insert
nothing
these
to do
objects
with
into
pushing off.
space.
You need
Maybe
to stop thinking about
Okay,
pushing
okay.
it off.
What I'm saying is, I get that they can be inserted into space, but my question to you is, how do you explain the movement and the ability for these things to actually fire off into dead space and change positions in orbit? How does that explain?
No problems, because simply because of Newton's third law. The gas, nobody tries to ignite anything up there. You'd probably, this is way too risky for any satellite. Okay, so there's no fire, there's no igniting any kind of fuel. What we have is we have gas.
Yeah.
Okay, and because there's so little resistance up there, it only takes a tiny whiff for a microsecond. Okay, so sometimes a second would be a very long time to release the gas, because that's all it needs, and all it needs is that release the gas. Okay, so that sort of motion. It's not trying to push off anything. It's just the release of that caused that motion. That motion that happens just like you have. If you hold a gun against your shoulder, you're going to feel that butt hit your shoulder. It's that motion that pushes the satellite, that makes that satellite move in a particular direction. And because there's no resistance, anything will go in the same direction unless there's a force acting on it to push it into another direction. So what we do is we'll fire off the thruster in a particular direction to make it go somewhere. We might have to fire off 2 or 3 thrusters around it. And then once we get that into the particular orbit that we want, we turn all the thrusters off. Okay, that satellite will continue in its and sometimes the satellites will actually they'll lose their orbit.
Yeah,
And
the
they don't lose
decay.
their orbit they don't lose their orbit by falling down. They lose their orbit by falling up, if that makes any sense to you.
Okay.
Okay? In other words, if something gets slower, it goes higher, not lower.
Hmm.
Okay?
I thought
So
orbital decay was when it was being pulled by the Earth's gravity. I guess
okay,
I was
that's a
wrong.
different that's a whole different thing altogether.
Okay.
This if a satellite's like that's if that happens to a satellite, it's speeding up. It's going faster if that happens to a satellite. If it loses its orbital distance, it's going faster, not slower.
Okay.
Okay.
So I still disagree with that. I still think that there hasn't been one experiment here on Earth that actually can recreate what you just said. That the fact that a tuft of air can come out of something in a vacuum and change orientation, like that just doesn't happen because there's been experiments where they've done just that, where they've let out air within a vacuum and not nothing, no movement. So
Oh,
so where is the inertia? Where is the the energy that's being displaced that's causing this thing to move? How is that relaying off of anything? You know what
do,
I'm
do
saying?
you do you think for a moment that I told you before that, let's say for instance a medium cost satellite $75 million. Okay.
Sure.
Do you think a $75 million satellite would be up there and we don't know how to make that thing move? Do you think that's even possible? Do you think we would have even that those people would have trusted us with their $75 million if they thought for a second that we didn't know how to make that satellite move from one orbit to another? Seriously.
I mean, I wouldn't have played Minecraft for so many years had I not realized that me jumping online was going to get a reaction from other players. So, yeah, I mean, you expect what you expect. I get that. To me, that is not a that's not a
No,
substantial proof.
okay. Look, I get that, and try to put this together and try to think like a scientist does.
Sure.
We need to. What we do is we put together a whole bunch of different things, different evidences.
Yeah.
Okay, a whole bunch of them, and we say, look, if I were a betting man, which one of those would I choose to put my $75 million into? Okay, that's really the kind of decisions that I'm making as a scientist. So
But
when I first started out, I was an explosives scientist. Okay, I was an explosives chemist when I first started out. I didn't start out being a physicist. Okay, I was so at that stage over there as a chemist. This is making decisions about chemicals in order to achieve certain outcomes. Okay. Now I didn't. I'm not the one who discovered atoms. I'm not the one who discovered how molecules work. But I can tell you what. I used that information that was given to me by those people who did, and I produced explosives with it. That worked. Okay. So what you got to look at, you've got to say, look, I'm bringing together all the evidences, all the different things, and now I'm making a comparison. And
yeah,
I'm saying, which one do I reckon? Now, from my perspective, you've got to walk in my shoes now, all right? Try to walk in my shoes. Which one would you choose? I've put a satellite up there. This is my evidence, all right? It's got a camera on it. I can see the Earth over there, okay? That blue stuff over there. I can see that it's curved. I saw it was curved anyway when the rocket was going up because we have a camera at second
GoPro.
stage.
Okay.
All right, all right. I could see all of that. All right, and well, I tell you what, for all the things that it is, if it was flat, that would be a strange way for it to be flat. I can tell you that now. Okay,
Okay.
considering the direction that we just came off it. Okay, no. The thing is definitely spherical. I can tell you why it's spherical. I can even tell you how it's spherical. I can even explain to you how the water works. Okay, which is another one of the big flat Earth things that
Oh yeah.
the big flat Earth.
Centrifugal forces. Yep.
It's that how water sticks to a ball. It's a big misunderstanding. So is what is up and what is down. Okay, so you see a sphere. You see the images of a sphere in space, and then you automatically think about the top as being up and the bottom of it as being down. It's not. It's not like that. Things don't go round and then upside down. The person who's in the aeroplane is always up above the ground. Ground is always the place that you're above. Airplanes, all they have to do is make sure that they are the same distance from the ground all the time, actually from the center of the earth. Okay, that's their as long as they maintain that altitude. But of course, they have to go up and down because sometimes they go over Indonesia like they do over here, and they have to fly higher. Okay, sometimes they have to fly over Everest. They have to fly higher. Okay, so they will change like that. But overall, they're going around a sphere. Look, I get it. I get all of that where that comes from, the flat Earth thing. But to be honest, it comes from a lot of misunderstanding, and that if we can clear up that misunderstanding about how the flat Earth works, I'm pretty sure I can. You're a smart bloke. If I have you in my class for an hour, you will not be a flat earther.
I don't know. I don't know
Okay,
about that.
I guarantee it.
I'm always willing to listen. That's the thing. I
No,
do.
and I appreciate this conversation that you are willing to listen. Okay,
Yeah.
that's terrific. And like I said to you before when we were speaking, this is the first time I've actually spoken to a person who thinks that the Earth is flat, and I'm amazed, and I'm intrigued as well, and I'd love to have you in my class as a student, so that you can go, you can have a look at it from our perspective. When you standing on over there watching a rocket actually go up, and then you go inside and you start looking at the telemetry and you actually see the cameras on it, it's actually awesome. It really really is. It never fails to, the hairs in the back of my neck never fails to rise up every time that happens, even though I've seen it hundreds of times, literally.
Well, I
Okay.
Professor Phil, I do have a question. I mean, I we can wrap this up now because we're already at the. I think we're at 2 hours already. So, but in the future, if we can still exchange information, that would be great.
Yeah.
Uh,
Oh, anytime.
I have some questions. One of the things
Okay.
that I would love to information I would love to get from you is like the type of cameras that you guys are using on these systems.
Yeah.
Um,
Okay.
from brands to where they're positioned and things like that.
All,
And
all I can tell you is that they like her. Okay. I can't give you any other type of specific type of information about. But there's things that I'm not entitled to. I can't even take a camera on site.
all right, and I don't want to put your life in jeopardy, from
No,
speaking too
I
much
can't. I
or
can't even. I can't even do that. Actually, the our space center is a military zone.
okay.
Okay.
But yeah, let's
So
if it's okay with you, I'd love to remain in contact with you and to continue this conversation
absolutely.
over some
Please,
time. Yeah,
please,
that
please
would be
do.
amazing.
Collect some questions from your followers, and let's do this again and answer more specific questions that they might have, because they might be a bit frustrated. They're thinking you didn't ask me enough tough enough questions, did you?
Oh, they wanted me to just pin you down, but I,
I bet they did.
I was being
Okay.
nice. I'm being nice. I love you,
I bet
man. Like you. I think deep down inside you, you're looking for truth, and
I am.
to me that's you're gonna get there. We're all gonna get there. I'll get
I'm
there.
just,
You'll
I'm
get
just, in,
there.
I'm just in a different place, and I'll bet you'll get there too. Okay.
Vice versa. So yeah, man. Thank you for coming on, and thank you for having this conversation. It's been wonderful. Uh,
You're welcome.
I hope you guys in the chat weren't pulling out your hair through the whole thing. I'm sure
They
a lot
probably
of you
were, yeah.
flat earthers are like, "What the heck is this guy saying?" But guys, thank you for coming by and watching this great discussion. I wouldn't even call it a debate. I would just say it's just a friendly chat.
Yep.
And yeah, thank you so much for coming here, guys. And I just want to say that maybe in the future I can have Professor Phil back on if that's okay. Um,
Yeah. Love to do it. Love
awesome.
to do it
Awesome.
anytime.
So don't go anywhere, Phil. I'm going to end the
All right.
stream with these guys and then we can wrap it up. All right.
Okay. Not a
All right,
problem.
guys. Thanks for being here. Much love. Yeah, stay
You too.
tuned.
Okay.